Okay, let's commence here. We're going to do a little bit of a refresher here just to kind of fluff up our memories. Um, is anybody here? Is the gang all here? Oh yeah, we got lots of folks showing up. Okay. So since we got a lot of you in the audience here, we'll get going and we'll do a couple of examples. Just make sure we all know what's happening. Hmm, where's Waldo? Ah, Waldo was hiding behind Godzilla. Silly Waldo. All right, so we're going to practice factor and solving, and you're like, we've been graphing parabolas. Why on earth does he want us to practice this? Well, you might find out next day. First things first, of course, we decide, hey, two sets of parentheses would be the way to go. And of course, we see the x squared, and everybody knows that's going to be what? X times x. Then we look at that negative 35, and what does that negative on the 35 tell us? That's right, the signs do not match. About the only thing I can think of for 35 is 5 times 7, right? 5 times 7 is 35. But notice there's a positive 2 on that 2x. So the larger number needs to be positive. I need a positive 7 and a negative 5, right? 7 take away 5 makes 2. 7 times negative 5 makes negative 35. Now, don't forget to write down the answers. Right? If x plus 7 has a quantity of 0, the value of x has to be negative 7. If x negative 5 happens to be equal to 0, x has to be positive 5. Right? Don't forget, if you see the x plus 7 inside parentheses, the answer is actually negative 7. If you see x minus 5 in parentheses, the answer is actually positive 5. Okay, let me catch up because I'm sure some of you have already started doing this next one in your head. Two sets of parentheses, quite obviously. X times x makes x squared. Positive 72. What does that positive tell us? That's right. That tells us the signs have to match. The negative on the 22x tells us they're both negative. Now, off the top of my head, the only thing I can think of for 72 is 8 times 9. But I don't think 8 and 9 add up to 22. So instead of making random guesses, I will grab a calculator. And I'll try 72 divided by 1. 72 divided by 2. 72 divided by 3. Notice I'm just going in order. 72 divided by 4. 72 divided by 5. 72 divided by 6. 72 divided by 7. 72 divided by 8. And I'm going to stop there because I see that 8 and 9 are almost identical. And say, hey, if 8 times 9 is 72, if I try 9, I'm just going to get the repeat. Right? So I'll say, okay, so 72 divided by 1 worked nicely. So I could do 1 plus 72. 72 divided by 2 got me 36, so it could be 2 plus 36. 72 divided by 3 was 24, so 3 plus 24 is a possibility. Next one looks like 4 times 18, so I can try 4 plus 18. I won't bother with 5 because that came out as a decimal. If we divide it by 6, we got 12. I'm like, hey, I probably should have had that memorized. 6 times 12 is 72. I won't bother with 7 because that was a really messy decimal. And then, of course, 8 times 9 was 72. So I have to think about 8 plus 9, right? Those are my choices. Those are the 6 pairs of factors that multiply to be 72. And again, I went in order with the calculator. Otherwise, if I just make random guesses, I could be here all day long. And eventually you'll say, hey, you know what? 4 plus 18 is the pair that adds up to 22. So negative 4 and negative 18 adds up to negative 22. Negative 4 times negative 18 makes the positive 72. And then, of course, remember that you've got to actually write down the answers, and the signs are always opposite of what you see inside the parentheses. So I'm glad the gang was all here for this. And we got a nice little short worksheet. And if you're trying to figure out what this factoring and solving has to do with our parabolas, come back to class tomorrow, and you're in for a little bit of a surprise probably.